Okay, dear students, so let us see this question. I am now going to do another type and I'm going to do this question. So there are other questions also you can try, but I think the statement for this is big one. That is why I'm choosing this question for me. So let us first of all write what does this summation means. So summation this I into 3 raised to power I. So how will it be expanded? It will be like this. 2 into 3 raised to power 2 plus 3 into 3 raised to power 3 and likewise up to n multiply by 3 raised to power n, and the proposition is that this is equal to 3 by 4 2n minus 1 3 raised to power n plus 1. Quite a big statement, I would say, and this is going to be a long question, and we have to be careful for not to make any clerical mistake here because there is no coming back. No. So this is the complete statement. So let us take step number one. I'm leaving step number one to you because I need more time now. And step number two is the assumption where I substitute n is equal to k simple. So the statement will become like this. Plus k into 3 raised to power k. This is now coming out to be equal to 2k minus 1 3 raised to power k plus 1. Now this is the complete statement, and this is the assumption that we are making in this question now. So we would be using the same assumption in step number 3. So in step number 3 we are just going to substitute n is equal to k plus 1. So it means that in this complete series I am just going to add one more term there. So I have written this complete thing, this up to this, plus the last term, and the last term is k plus 1 3 raised to power k plus 1. Okay, now this is equal to 3 by 4 into 2k. Now here also we would be substituting k plus 1, so it will become 2k plus 2 minus 1 raised to power 3k plus 1 plus 1. Now we are just left with mathematical arithmetic tools, and we need to prove these two statements to be equal to each other. So the first thing first, what I'm going to do is we are going to make use of this assumption. We are now going to substitute this complete term for this big expression. So it will be 3 by 4 into 2k minus 1 3 raised to power k plus 1 plus k plus 1 into, I'm dividing it like this, I'm writing it like this, 3 by 4 into 2k plus 1. Now 2 minus 1 is plus 1 into 3 raised to power this multiply by 3 plus 1. The first step that I'm going to do is multiply the whole equation by 4 by 3 so that this 4 by 3 and this 4 by 3 gets cancelled. Okay, so I would be remaining with 2k minus 1 raised to power 3k plus 1 plus this equation will be multiplied by 4 by 3. So it will be 4 into k plus 1 divided by 3 into 3 raised to power k into 3. This 3 gets cancelled with this 3. This 4 by 3 gets cancelled and we are left with 2k plus 1 into this and plus 1. So this plus 1 and this plus 1 gets cancelled out. So now we are cancelling 3k, 3k and 3k. So it will become 2k plus 1 plus 4k plus 4 is equal to 2k plus 1. This 3k, 2k plus 1 into 3. This gets cancelled out. So it will be 6k plus 6k, sorry, 2k minus 1. 6k minus, oh sorry, plus 3. And here we have 6k plus 3. Yes. So right hand side is equal to left hand side, my dear students. It was little cumbersome calculations involved there, but that is what we have to do here. That is what makes this chapter difficult for many of the students. So if you are able to handle this situation, you will be one of those students, those who are able to do these questions. Okay. So with this, all the best.